What we're going to do in today's video is we're going to take a look at the derivatives of the basic trigonometric functions. And taking these derivatives relies on kind of two crucial assumptions over here, and that's that the derivative of sine of x is equal to cosine of x, and that the derivative of cosine of x is equal to negative sine of x. And I've also written out the quotient rule over here because it's going to prove very, very useful when we're taking these different derivatives. And so essentially, what we're going to do is we're going to use these two assumptions, which have their own proofs, which we will delve into a little bit later on. We're going to use these two assumptions and the quotient rule in order to determine the derivatives of these different functions over here. So let's go ahead and actually do that. So the derivative of tangent of x. So we know that we can rewrite tangent of x in terms of sine and cosine. We know that tangent of x is just sine of x over cosine of x. And we know how to take the derivative of a quotient, right? And we have all of the information we need. We have the derivative of sine, we have the derivative of cosine, and we have the quotient rule. So let's just go ahead and input these pieces of information into the quotient rule over here. So let's do that. So our numerator in this case is going to be sine of x. This would be our f of x in this case. And our denominator is cosine of x, so this would be our g of x. So we know that by the quotient rule, we have to take the derivative of the numerator, which is going to be cosine of x, times the denominator. So we have cosine of x, which is the derivative of the numerator, times the denominator, which is going to be cosine of x as well. And we're going to subtract that from the numerator, which is sine of x, times the derivative of the denominator. The denominator is cosine of x, and so its derivative is going to be negative sine of x. But we know that negative sine times the negative 1 over here, because we have a negative 1, negative 1 times negative sine of x is going to be positive sine of x. So we get sine of x times sine of x, essentially. It becomes positive. And we're going to go ahead and divide that by the denominator squared. So cosine of x squared, or cosine squared of x. We can rewrite the numerator as cosine squared of x plus sine squared of x, because we're just combining the sine times sine and the cosine times cosine. And we're going to go ahead and divide that by cosine squared of x. And then we can rewrite cosine squared of x plus sine squared of x. So we know from the Pythagorean identity that we can rewrite that as just being equal to 1, right? So we'll get 1 over cosine squared of x. Again, this just comes from the Pythagorean identity. We can rewrite 1 over cosine squared of x as 1 over cosine of x squared. And we know that 1 over cosine of x, this is just going to be secant of x. And so here we'll get secant squared of x as our derivative. So that is the derivative of tangent of x. And, I mean, what we can do is we can do the same thing for cotangent of x over here. I'm not going to go through the entire proof. It's not with respect to time, it's with respect to x. But so essentially we can rewrite cotangent of x. We know that that's just 1 over tangent of x. We can rewrite this as cosine of x over sine of x, and then just use the quotient rule. And so we can go through all the steps, and I'll leave this one up to you. It's a very simple proof. We'll just end up with negative cosecant squared of x if you go through the entire proof. So that is the derivative of cotangent of x. And then we can take a look at secant of x, and this one's going to be a little bit simpler. So we can rewrite secant of x as 1 over cosine of x. And then we can kind of establish our numerator and denominator function. So if we say that 1, this is our f of x. If we say f of x equals to 1 is our numerator function, then we can say that our denominator function is going to be cosine of x. So this would be our g of x. We know that if f of x is equal to 1, then f prime of x by the power rule is going to be equal to 0, right? And so what we can do then is we can just use the quotient rule with these two pieces of information and kind of our established numerator and denominator function to get the derivative of secant of x. So what we'll do is we'll take the numerator. If you want to go and take a look at the quotient rule again, we'll take the numerator's derivative times the denominator. So the derivative of the numerator is 0 times cosine of x, which is the denominator, so we'll get 0 times cosine of x. And then we'll subtract from that the numerator times the derivative of the denominator. Derivative of cosine of x we said is negative sine, so here we'll get the numerator, which is positive 1, times negative sine of x, which is our denominator, or the derivative of the denominator rather, and then our denominator squared, which will be cosine squared of x. We can go ahead and simplify this. We know 0 times cosine of x is going to be 0, and negative 1 times negative sine of x, that's just going to be positive sine of x, and we're going to divide that by cosine squared of x. Now we can rewrite this expression. We can separate the 1 over cosine squared of x. We can rewrite this as sine of x over cosine of x times 1 over cosine of x. We didn't change anything. We just kind of rewrote this a little bit. But now we have it in a way that we can express it in terms of other trigonometric functions. So we know sine of x over cosine of x, this is just going to be tangent of x, right? So we can rewrite this as tangent of x. And then we know that 1 over cosine of x, this one right over here, is just going to be secant of x. And so then we end up finally with our derivative of secant of x is equal to tangent of x times secant of x. And then finally, we can go ahead and take the derivative of cosecant of x. And again, I will leave this one up to you as well because it is a fairly simple proof. We just rewrite cosecant of x as 1 over sine of x, and then we use the quotient rule. We establish our numerator and denominator functions, and we just input the pieces of information we need. And if you go through the proof, you will end up with negative cotangent of x times cosecant of x. And that right over there is your derivative. So definitely you don't need to memorize these. The only one that's really worth memorizing, or the only ones that are worth memorizing, are the derivative of sine of x and cosine of x, because if you use these two pieces of information and the quotient rule, then you can determine the derivatives of all of these different functions over here. I encourage you to go over the proofs of cotangent of x and cosecant of x because it's fairly simple and it will kind of help you get a deeper understanding of how you can actually use these different rules to take the derivatives of these trig functions.